Hi everyone. In the last session we have seen fundamental torque equation and the conventions for speed torque. In today's session we'll see an example for multi-quadrant operation. So as a best example we can take the lift as an example, and in the 4 quadrant how the lift will be operated with forward motoring, forward braking, reverse motoring and reverse braking operation, that we'll see in this session. So here the assumptions are, let us assume this right side of the pulley is cage and the left side of the pulley is counterweight. And one more assumption is here loaded cage. If it is with hatched portion means that is loaded cage. If it is empty means simply it is without hatching portions. And counterweight is always with hatched portion. And here loaded cage is greater than counterweight. So here loaded cage is, that is one more assumption, that is loaded cage is more weight than the counterweight, which is on the left side of the pulley. Okay, so we'll see one by one. In the first quadrant, if you see the first quadrant, in the first quadrant it is loaded cage. Let us assume that the loaded cage or the cage at ground floor need to go for top floors, that may be 1 or 2 or 5, anything. Okay, now the loaded cage need to run in, or the drive need to run in the motoring mode to lift the loaded cage upward direction, that is forward motion. In the upward and forward directions of motions, the forward direction is nothing but upward direction. So in the forward direction, if lift wants to move means the drive need to operate in the motoring mode. The conventional directions for the speed and torque are like this. So when the speed is in the counter clockwise direction, that is assumed as a positive direction, and also torque is also in the counterclockwise direction means that is also assumed as a positive direction. Now both speed and torque, if those are in counterclockwise direction, those are in the positive direction. Okay, and it will be in the negative direction if it is vice versa. Okay, so here if you see that the loaded cage need to move upward direction, that's why the speed of the drive should be in the counterclockwise direction. So here speed is positive. Here we have assumed that the speed, positive speed on the, or speed is y-axis, torque is x-axis. So positive speed, positive torque will come in the first quadrant. So here if you see that, if we, for this convention of this loaded cage and counterweight, at these positions the drive need to operate in the forward motoring mode. How means the loaded cage need to move upward direction. To move upward direction, the drive need to rotate in the counterclockwise direction. So here it need to rotate in the counterclockwise direction means the convention is mentioned with counterclockwise direction. So the counterclockwise direction of rotation of the motor will move the loaded cage upward direction. But loaded cage is more weightier than the counterweight, that's why your load torque will be produced in the clockwise direction towards the loaded cage. To oppose this load torque, the motor or the drive need to produce the motor torque or main torque, which is in the opposite direction to the load torque, that is in the clockwise direction. So here speed is in the counterclockwise direction, your motor torque is towards the loaded cage, and to balance this load torque, motor torque need to be produced in the opposite direction. So this is the conventions. If we see these conventions, here load torque is in the clockwise direction, and speed and motor torque both are in the counterclockwise direction. That's why it came in the first quadrant. And when both speed and torque are positive, then power is also positive. When power is positive, the drive is in motoring mode. When speed is positive, that is in forward motoring mode. This direction will come with the speed convention. When speed is positive, that is in the forward direction, and when power is positive, that is in the motoring mode. So that's why the drive now it is in the forward motoring mode. So here one more assumption is that the load torque is always constant and it is independent on the speed. Load torque is always constant and it is independent on the speed. Irrespective of your speed, your load torque either it may be in the clockwise direction or counterclockwise direction based on the whether it is loaded cage or empty cage. Okay. So now the drive is in forward motoring mode. Hence the lift will move upward direction, because to lift the loaded cage, the drive need to run in the motoring mode. So it will go slowly to the first, second, third and so on in the forward direction, go upward direction. So suddenly if we need to apply the braking, or let us take the, if you see the second quadrant, just here what I've changed is the counterweight is at same position, but instead of loaded cage I have taken empty cage in the second quadrant. If we take the empty cage, now speed has not changed. Speed is in the positive axis, so speed is counterclockwise direction. That's why omega m is positive. Omega is positive only. But what will happen to the load torque? Earlier load torque is in the clockwise direction, because loaded cage is more weight than the counterweight. Now here loaded cage is weightier. Here counterweight is more weight than the empty cage. That's why here load torque is in the counterclockwise direction. To balance this load torque, we need to produce the main torque or motor torque in the clockwise direction. But earlier your motor torque is in the counterclockwise direction. Now you need to reverse the motor torque direction in the clockwise direction. That means here if it is positive torque, here we need to reverse the motor torque, negative torque. We need to produce the negative torque. That's why this is minus T torque. So this negative torque can be produced to apply the brakes, or this negative torque will be produced by using the power electronic devices. This we'll see in detail in the next sessions. So this negative torque will be produced by using the power electronic devices. Once that means we need to reverse the current direction. Once current direction is reversed, means torque is directly proportional to the current, hence the torque will get reversed. To balance this load torque, we are reversing the motor torque. Now you see what is the power, your omega m is positive, torque is negative, hence power is negative. Once power is negative, that is no more in the motoring mode, it will enter into the braking mode. Now it is in braking. Whether it is forward or reverse means your speed still it is in the forward direction only, that is in the counterclockwise direction only, our assumed direction. So hence forward braking mode with this operation. Next, if we see the third quadrant operation, simply I moved the lift to the top floor. Now your counterweight will reach to the ground floor. So here again I have considered the empty cage. Now this empty cage slowly it need to move downward direction by balancing this counterweight. Always at steady state your motor torque should be balanced by the load torque, or load torque should be balanced by the motor torque. Okay. So here if you see again this convention, here counterweight on the left side, empty cage on the right side of the pulley. So now if you see here, this empty cage need to come downward, but always it will try to be at top floor only, because counterweight is more weight than the empty cage. We need to pull this counterweight upward direction, or we need to pull this empty cage downward direction by using the motoring operation here. Then only this will come downward, right? So that's why what is the speed, direction of the motor? It should be in the clockwise direction to move this empty cage downward. your motor need to be run in the clockwise direction. Clockwise direction. What about the load torque? Your load torque, as counterweight is more weight than the empty cage, your load torque will be produced in the counterclockwise direction. To balance this load torque, your motor torque will be produced in the opposite direction to the load torque, that is in the clockwise direction. Now if you see whether what is the position of this drive, so what is the power? Power P is equal to T into omega. Now T is in the clockwise direction, omega is in the clockwise direction. The conventional directions are counterclockwise direction. When both speed and torque are in the counterclockwise direction, that is positive. Now both are reversed. That's why here power P is equal to minus T into minus omega. Hence it will become plus, right? Power P is equal to T into omega. Positive. Power become positive. But what about the speed? Here speed becomes reversed, right? Earlier it was in the counterclockwise direction. Now it comes into the clockwise direction. Speed becomes negative. When speed becomes negative, it is in the reverse direction, and as power is positive, motoring. Now the drive enters into the reverse motoring operation. Next we'll see the fourth quadrant. In the fourth quadrant, again speed is in the same direction, that is in the negative direction only. Only your torque should become opposite. That is, earlier if torque is negative in the third quadrant means it will once if it is enter into the fourth quadrant means your torque should become positive, but speed should be as it is, like in the negative only. Further, the convention is, now let us assume the lift is again at the top floor only, but counterweight is on the left side, it is at ground floor. Now this lift is or cage is loaded. If it is hatched portion means it is loaded. Now loaded cage is more weighted than counterweight, right? Your speed direction, so here we need to apply, because if the loaded cage need to come downwards means, then we need to apply the braking frequently at each floor. For that we need to apply the braking. What is the direction of the motor means? We need to bring this loaded cage downward. That's why the speed of the drive should be in the clockwise direction only. Clockwise direction. What about the load torque? Load torque, as loaded cage is more weighted than the counterweight, load torque always it will be produced in the towards the loaded cage in the clockwise direction only. If we don't develop the opposing torque to this load torque, simply a loaded cage will come suddenly downward. It will fall to the ground floor when there is no opposing force, opposing torque. That's why we need to produce the opposing motor torque which will balance this load torque. That motor torque should be in the clockwise direction to balance this load torque. Now if you see the convention, your speed is negative, torque is positive, because counterclockwise torque is, we have assumed that is positive. So power P is equal to T into omega, it will become negative. Already your speed is negative, so that's why as speed is negative, reverse, as power is positive, it is in braking operation, a reverse braking operation. Okay, so reverse braking operation. In this way we can get the multi-quadrant or 4-quadrant operation by using the power electronic devices. This is the best example for the 4-quadrant operation or multi-quadrant operation. In this multi-quadrant operation, we have taken lift as an example, and our assumption is loaded cage is greater than counterweight. By using that assumption, we have seen all type of operations like forward motoring to forward braking to reverse motoring to reverse braking operation. Okay, thank you all.